All right, I have a few slides just to kind of set the context, and then we'll dive into some command line stuff. Hopefully you like the command line, because that's what we're going to be looking at today. I want to do this presentation on Docker, something I've been looking into. I really think if it's not Docker, something like Docker is going to be what it is moving forward as far as delivering applications. It makes a lot of sense conceptually, and I think the technologies and tool sets around doing this type of self-contained application with all of its resources is going to be the way that things move forward. So, how many in here are familiar with Docker already? Okay. So this is straight from the docker.com site. Docker allows you to package an application with all of its dependencies into a standardized unit for software development. So Docker, I want to preface this a little bit, Docker is not the only technology out there for containerized applications, but in some of the other ones I looked at, it is the most developer friendly. They took they paid a lot of attention to how you get it into Docker, not just paying attention to how you, from an infrastructure standpoint, manage those applications. They also, looked at the developer approach to it a little bit more closely. There's a competing tool out there, or just another option, not necessarily competing, called Kubernetes, which came from Google. And if you go read up on that, it's all about managing resources, and it's all the infrastructure side and how it makes all that great. And if you go try and find all the nice tutorials on how to package your app to put in that environment, it's very slim. And in Docker, it's the other way around. You can find all kinds of stuff on how to Dockerize your apps. And I think the reason Kubernetes is around is because it works for Google, and some folks don't think the Docker Swarm stuff is necessarily up to speed with a full like ISP type hosting of the containers. But we'll get into the Docker components, but the Docker Swarm is the environment that allows you to manage a whole bunch of Docker containers. But we'll talk about the whole stack here. So the concept behind Docker is it wraps up all the software into all of its dependencies, all of them into a nice little container. So when you go to deploy it, it all goes together. So you're putting the exact same environment and bits in your QA, and the exact same environment in your UAT, and the exact same environment in your production. The only thing you're really changing is your external interfaces as to what IPs it's pointing to, and if you have a storage need, what volumes it's pointing to as far as where it's writing information. But from the standpoint of the container, you can build a container once, and you can deploy it to all three of those environments without any of your stuff changing. In software development, a lot of times, if you're in a TFS shop, it's one of my pet peeves that they tend to follow the model of they have a branch for QA and a branch for UAT and a branch for production, and when they get ready to push, they rebuild the app for each one of those environments. And to me, that's dangerous, because you're recompiling your app. Yeah, you're doing it in an automated tool. Everything should be the same. You should get the same output, but you should build the bits once and deploy those bits in all three environments, so you're limiting the scope of what changed. With Docker, you can go one step further, and you're not just limiting your application bits, you're limiting the changes to the actual environment that it's executing in, because you're putting the whole thing through all three stages. So this is just a little visual of what a Docker container has in it. It has your application. I want to emphasize server application. This is geared towards server hosted things, not desktop apps. So it's about things that you would reach by communicating over an IP address, right? So those server technologies. Within that container, you'd have your application, the libraries needed for that application, whether you're doing it on mono ASP.NET, or whether you're on Node or Java or Python, whatever your backend, all the libraries, everything that environment would need to execute. And then a minimal OS. It's only what OS your app needs to do what it needs to do. If you're doing a web server, you really only need some file handling, some networking, and those type of things. So you can get a pretty small slice of the OS in there to deploy your app. So the container itself is then run in what's known as a Docker machine. And the Docker machine itself can run many instances. It can either run multiple instances of the same image. An image is what you build. You build your app out into the container. It's got your app in it. Hopefully your app is built. If it's a web app, that's built so it can be web farmed. It's can be scaled wide. So you can have one image out there of your web app, and then from a Docker machine standpoint, you can deploy multiple instances of that image and scale them wide and do the load balancing and all that. And that's where things like Swarm and some other things come into place to managing those IP resources and how the traffic gets routed to them and such. You can also run multiple instances of different apps in the same Docker machine. So the machine's function is to host the containers. It's to manage the resources that those containers need from a memory standpoint, storage standpoint, networking. It controls the outside access to the containers. So your container only has your web app in it. So the only thing that needs to talk to that container is port 80 or whatever port your web app's going to be in. Or I have an example here. We're going to be hosting Mongo and MongoDB in a container. So the only port we need on that is 27017 to get to Mongo. So all the other ports are locked out. So you don't. So it's isolating that application container. Docker Swarm is another tool from Docker that allows you to basically host multiple Docker machines across resources. So think of it. If you're familiar with VMware, think of it like an ESX server or something like that, where you can have multiple physical pieces of hardware, but manage all your virtual machines across those physical pieces of hardware. Swarm provides that for Docker, where you can have multiple Docker machines on multiple pieces of hardware, but manage them all as if they were one Docker machine and put your containers on. You really don't know which physical hardware you're running, or don't care which physical hardware it's running on. You're just managing all that hardware as a swarm and putting the containers wherever you need to put them. When you Dockerize your application, you're creating a Docker image, and that's the kind of in a repository. It's the image. It's ready to go. It's ready to execute. Where it just has to be matched up with what external access you're going to give it, and when you're going to launch and run it. And then when you launch and run it, then it's an instance, and that same image can be used to launch multiple instances. So the example I used earlier, like web farming your app, you can launch multiple instances of the same image to scale up and down as you need to scale up and down. Docker is a commercial company. They have to make money. Part of the place where they make their money is they're using open technologies for a lot of this, but the Docker Trusted Repository is the place where you would put your Docker images. You build these images, you got to publish them out somewhere so that the Docker machine has access to them, especially if you're doing a swarm, if you're doing across a bunch of hardware, you want to be easy to access those images. So Docker Trusted Repository is the tool they provide, which you license, that allows you to securely put your images out there so that they're not accessible by other people and that kind of thing. So it's the holding spot for your images that you've created that are ready to go to production or whatever environment. Docker Hub, I'll go out to it in a second. The Docker Hub is Docker's public repository of Docker images, and if you go out there, there's hundreds of them. People have already created Docker images that have Ubuntu in them. They've created Docker images that have Node in them, ASP.NET, and when we start looking at how you build a Docker container, you always start with some base image. And that base image, it pulls it by default from Docker Hub and then puts your stuff in it and builds your image. So we'll step through that process in a minute. But so Docker Hub, you can go out there and peruse and see all the different stuff. You get an account up there and you can publish your own images back up there if you're building something that's open source and you want to make that collection of things available to people. You can publish it back out there. When they do a search for the keywords, they'll find yours. So, to build the image, you run the Docker build command. It looks at a Docker file, and the Docker file explains how to package up your app into that Docker image, and it does all the work for you. And then to run the image, you do the Docker run command, and it runs the image. We're also going to look at, towards the end, another tool called Docker Compose, where these Docker images are meant to be components. So I have my web component. I'm not going to put my database in that container. My database is going to be someplace else. Well, if I'm going to use MongoDB as my database, I can have a MongoDB container. But again, it's a container. I don't want to put gigs of database data in it. I just want MongoDB to execute in that. So I define a volume, and that volume is storage external to the container, but it's controlled by Docker machine. So you can have a SAN or some other form of storage that's available to your Docker machine, and then through your, when you run your Docker image, you marry up the fact that this path inside of your Docker image is pointing to this external path, which is some form of storage. So theoretically with MongoDB, if you were going to build one really for production, in Mongo you normally put, the /db/data folder where Mongo puts all its files, that's really its storage of its database. You'd want to map that to a volume that's external to the container so that all your data is stored in some manageable storage of some sort. So this is just simply illustrating that there, where I can have an ASP.NET image running the app. I can have a MongoDB container running MongoDB bits, but then I have a volume defined that I've pointed to the MongoDB container, and that's where Mongo is actually writing its data when it stores it, when it persists it.
So would that volume have to be the same everywhere the containers run? Like you're hard coding the volume to a drive?
That's part of Docker Swarm and Docker Machine. When you launch, you're marrying up that internal path to some external.
Okay.
So if you have the concept of a swarm and you're doing some kind of replication or multi-thing with Mongo, you'd have to make sure that that volume storage that you're using was available to all your physical machines that your swarm's on, so that when you map it to if you run the instance on any one of them. Okay. But that's the same problem you'd have. It's not a problem, it's just the way it works. If you launch anything, if you want to do anything across servers, there's no magic. So the Docker Toolbox itself, this is what you run on your development environment. We're not going to get too much into the server side management of this stuff with the time we have allotted. I'm going to work more through how the containers are built, what's in them, what it looks like for different types of code projects. But to do that type of thing, you'd use the Docker Toolbox. It contains the Docker client, which has the commands for running and building and manipulating your Docker containers themselves. Docker Machine is the actual environment running locally that manages those containers. And in this case, they're kind of in transition, but right now if you're on a Linux system doing these type of things, the Docker Machine is native to Linux, so it's not virtualized. It's part of the Linux system, and it runs in there. On Mac, like on my machine, it's running behind the scenes. Docker has packaged up VirtualBox, and it runs a VirtualBox virtual machine as the Docker machine. and it handles through the Docker commands putting all the stuff in the virtual machine. If you launch VirtualBox client tools, you can see that it's out there, but you don't have to you don't have to go to VirtualBox to do anything. You just do it all through the Docker commands. And they're also coming up. It's in beta. I didn't get on the list. I didn't sign up to get one, but they were doing a controlled beta where they now have, for Windows and Mac, they have a more native virtualization. So you don't need to run VirtualBox anymore. You can run Docker machine on Mac, and it uses the native Mac stuff to run the Docker machine, and on Windows it uses the native Windows stuff. And I'm not positive of this, but I think on Windows you have to be at the Windows Update 2 level, where they're going to have the Ubuntu tool set as part of Windows 10. I'm not sure, but I think that's a requirement to do the native one, and that's why it's still in beta, because of where they're at with that. Docker Compose is the tool. We'll walk through an example of that. That's the tool that allows you to say, I'm deploying a solution, and it's made up of these containers, and I define those, and I can launch them all at once. So the solution run starts up and tears down all with one set of commands, rather than managing each one of those instances individually. Kitematic is a GUI that they're working on. It's in beta for the folks that need a GUI to look at the stuff. There's a GUI that shows you what images you have. It ties into Docker Hub and shows you stuff off Docker Hub. And if you install your own trusted repository, you can tie that into it. And it also will show you what images, what instances are currently running in memory on your local Docker machine, and just allows you to manage that type of stuff. But it's in beta. They're adding functionality. I'll show you some of it today. I use it as a shortcut to, they have the Quick Start Terminal is the terminal command line, and it launches automatically with all the shell environment variables set up, so all the Docker stuff works without you having to go in and run any special startup commands or something. It just starts the shell with all the Docker environment stuff already set up. You can also launch that from the Kitematic tool, which is what I normally do. I bring that up and then launch the command line, and it comes up with all loaded up with all the environment variables. So that's kind of the overview. So first thing I want to show, this is Visual Studio Code. How many people are familiar with that? It's the cross-platform Microsoft tool. I created a simple out-of-the-box ASP.NET app using Yo. The Yeoman tool has templates for building things. I just did Yo ASP.NET, and after I installed it, and it creates this shell of an app, so you're ready to go. All using it's using .NET Core, but I'm actually launching it on Mono, because .NET Core, there isn't like a Docker image for that yet because of where they're at with the state of that. The Docker image is actually a Mono image, but the same code runs on the Mono version. So these folders you see and all this is all template that gets generated automatically by the Yo ASP.NET tool. And you'll see one of the things that it creates out of the box is a Docker file for you. So we're going to use this. I can make it a little bit bigger here. Hopefully you guys can see that. Now. So we're going to break down a Docker file a little bit here. So the first line in it, the from, is where you're telling it what repository you're basing yours on. So somebody else has already done a whole bunch of work to create your environment, to create an environment. In this case, I'm using the RC1 ASP.NET one out of Docker Hub, and so the beginning just tells you which one you're referencing and which to start from. These next couple, this is updating inside of the container. It's running the Debian version of Linux. So this next command is setting things up to perform any updates that may need to happen on that that version of Linux that's running in there. It'll run the the apt-get commands to update that. And then they're loading SQLite here because this, again, just from a standard template, because some pieces inside of the UASP.NET, they use SQLite as the storage for some of their data. So it's needed in this, so they loaded it. They put this command in here. So the run commands allow you to run anything you need to run inside of the container to get it ready. So when you run this Docker file, it'll start with this image, and then it'll run these commands which are running inside the container to set things up. Then this section here starts talking about the app. So what this is telling it to do is to take the current directory and copy it into the app folder. Again, this is kind of a tutorial type thing. I don't necessarily agree with this because this is going to copy everything in there. And really all I need is the standard stuff you need for your production, which would be your bin files and your HTML content stuff is really all that needs to be in there for it to be executable. So to copy all this stuff is putting all your development tools in there, which is not a best practice, obviously, but they did that for simplicity's sake in this project. And then the work directory item there is telling it what folder is the working directory, the default folder inside of the container when it runs. So the run command is another step it's doing in there, and if you're familiar with the .NET Core stuff, it's running dnu restore, and it's doing that to make sure it runs against the package or project JSON stuff to make sure that all the dependencies for your app are loaded. So it's like NuGet in .NET, it's like the NuGet stuff. So when it creates this Docker image, it's going to run that to make sure all the dependencies are there. So then the next is it's exposing the port that the web application is going to be accessed through. And then the next one, the entry point, is where you're telling Docker that once this image is up, what do I run inside the container? So since this is a .NET Core running on Mono, it's got to run the dnx command. This is the project file. I had to add in order to get this to work correctly. If you're familiar with the .NET Core, when you run it on Mac or on Linux, it runs Kestrel as the web server. And I had to pass the server URLs command through to override the Kestrel defaults, because Kestrel by default does localhost, and if it's localhost, you can't see it from outside of the container. So this is telling it to listen on all IP addresses within the container, listen on all IP addresses at port 500. So
you added this Docker file generated from Yeoman?
Yeah, I had to make this change to it as far as these command line parameters, but the bulk of this was generated by the Yeoman stuff.
And which Yeoman generator did you use? Is it just the one from Microsoft? Or?
No, it's the one that you run npm Yeoman and it installs it. So
I just know there's like a lot of generators that are available to
Oh, you're talking about the generator piece. Yeah.
There's a whole list of them.
Yeah, I installed the. It was just they got the namespace for ASP.NET already.
Okay.
So I'm assuming it was Microsoft's or somebody that did it for them, but it's just the ASP.NET generator for Yo. Yeah. All right. So let's.
Excuse me. Quickly going back to the copy and working directory.
Mm-hmm.
Like in your perspective, I believe there are two different perspectives here. One, deploying the whole package into a container, and the way they have designed the copy and working directories, assume they still have the source files there in the container. That was your point.
Yeah, what you're building here is the container,
right?
The thing that's going to get deployed. So to me, it doesn't make sense for all your source code to be in it.
Yes, because in a different perspective, if you look at the way wherein there is a development team working on, and if there is a set of source code files available in the image within the container, you have all the dependencies taken care by Docker. So in a continuous rapid application development standpoint,
Mm-hmm.
I'd be able to bind mount the app work directly to my local host, do the changes, and then redeploy it directly. So that was one of the advantages of having a work directory map and having all those source codes present in the container. Because
Yeah, but if you're in source code development, I want all my source code in Git, and I want all my changes in Git. So if I'm going to work on it, I'm going to go into Git, I'm going to get it, I'm going to run a gulp script that's going to create my set of folders that's my production ones, and then I'm going to put them in this.
yes, in order to avoid that, we'll be able to map the Git.
Why am I avoiding it though?
Because assume like there are 4 or 5 developers working on the same environment, and it's really rapid. They don't have to redo most of these steps like setting up the environment, like npm install or write the task runners like dull, run. So
Yeah, but
it's
that you're talking about using the container as a
in a development environment.
Yeah, there's
Yeah.
a lot of people doing that actually.
Are there?
Yeah.
Mm.
They
Okay.
actually do the
Because
development in the container.
Okay.
that is one of the reasons I found value in Docker on the development aspect.
Yeah, but then you'd have to do.
Which
I
one's
would.
a separate one?
I wouldn't want to roll that. I wouldn't want to roll that container through QA to production. So then I'd have to go build another container.
Yeah.
No, it's not for QA or production. There are two different things.
Okay,
One,
okay.
the working directory and the setup is specific to development environments.
Okay,
It
okay.
reduces a lot of dependencies and other aspects,
Yeah.
which makes really fast.
Okay.
But you're right when it is on the QA or on the production environment, because we don't have to have a source code available.
Right. Okay. I
So you have
I understand.
separate Docker files, one for the development, one for the actual.
Well, something else you can do with this, if you use, instead of copy, if you say add, it'll take your host folder and make it available inside the Docker image at the work directory. So you can make changes directly to the files on your host system, and those changes are automatically seen inside the container, so you don't have to do Docker build again to build the container again. You can build it mapping the folder, and then you can make changes inside of Visual Studio Code or WebStorm. As soon as you're done with the changes, they're seen inside the container because you're mapping a folder directly and not copying. So you can do it that way too. That's different than what you said, because if I'm putting it all in there, I'm running it in the container and I'm doing my development in the container. But another way to do that would be just to do add instead of copy, which would make my local directory be the actual directory that's looked at when inside the container they look in the app folder. So if I change something, especially if I was doing front-end development, if I change an HTML file in my WebStorm, it's automatically changed in the container because they're really looking at the same files.
So I thought Docker images were immutable. You can change anything.
That's a philosophy or a process rule, not necessarily a technology rule. Yeah.
Because in terms of volume and bind mounting, they always operate in different layers. So it happens in such a way like once the setup from Docker file maps to our host folders, it first looks into that file system. If it's not there and the setting is not there, it goes by the image, the initial setup.
Oh, I see.
Yeah.
So the image is not that.
See, that's one of the other things about Docker that's nice, that it's the container self-contained, and when you go to run it, these things that are into building the images, you have some of these options when you run it also. So even though I define an app folder when I build the image, I can override that app folder when I run the container, and I can map it to a different folder for that instance that's executing. So anything you're defining there that's exposed, you can change at runtime. That's one of the flexibilities about it when you put it out in environment.
But what you're saying is true. Best practice in Docker is to make the image, the container itself, read-only, and to have a secondary Docker container, which would be considered a storage container, which would map drives and storage.
Yes.
And you keep that separate because as a microservice, you can actually restart the container almost instantaneously because it's read-only, nothing's happened there if your OS crashes. So if your container crashes and you want to restart, it's almost a pre-image that you go back and you pick up where you are, and that's where you get the speed from, is the read-only nature of the container.
But also, because they're so easy to manage, you'd probably have more than one, right? And if they're immutable and you're not writing stuff into the container, then there's nothing in the container that you needed to share. So you can fire up another one or another one or another one, right? And storage can be in a container, but storage is normally managed just as a volume that's some other storage mechanism. You can have a container that you put storage in. You could do that, but generally, then you'd only have one. So there's not a value of the container really because you have one.
So, like for instance, something that's acting as a database has to have some back end. So it would mount devices and use either network file I/O, or it would have local storage, but it would act as the container for that local storage, if that's what it's doing on the server.
But generally you wouldn't put, if you did a database container, unless it's just something you're doing for in your development world, you wouldn't put the storage of the database in that container. You'd put the storage externally in a volume or some other appliance.
You don't want multiple databases.
Sorry?
You wouldn't want multiple databases.
No, and if you have a multi-service database, something like I forget what's the Java-based, where you actually have multiple servers serving the same data, those could still be back to their own local, network file storage or, a container-based Docker container that's mounted.
All right, so hopefully we can this bigger here. Okay. That was enough. So I'm going to go through a few command items here. Docker machine is your virtualized machine that is going to run your Docker images in it. Because of the nature of the way it's running on the Mac and on Windows. Yeah. More? Okay.
Also, since you're starting from a mixed audience, is installing the tools, is there now one step, or do you have to do apt-get on all of the individual components of Docker?
There's a Docker tool install for most environments now.
Does it pull everything in?
Yep.
Okay.
Yep.
Rail has it in the extra.
What about Ubuntu? Is there an apt-get for that? Okay.
So in this environment, my Docker machine that's going to be hosting containers is running on that IP port. That's important because if I want to access any of my database websites, anything that I've created, I need to know. I need to put that in as the access point. So. These are a little hard to read. Let's see if I can. These are some of the Docker images that I've been playing with locally. So once you reference a Docker image or create one, it goes in your local repository and it's available there for use. So it's like cached locally. So this Microsoft, I don't know if you can see it, this Microsoft ASP.NET, that's the actual one from Docker Hub that when I referenced it, it pulled it down and kept it locally, so I can go now and create as many Docker images as I want of my own, using that as the base, and it won't have to go get it again. It's already local, so it's already cache local. You can see some other ones in here. Obviously, if you follow the Docker thing, you see I've done the tutorials because that's their Hello World, Docker Whale, Whale Sail. That's their little tutorial on the first page of the Docker site. So this ASP.NET Demo 3, that's the Docker container that was created based on that Docker file that we just walked through. So I can create another one here just so you get an idea. Let's see, where am I at? I'm in it. Okay, good. So if I do Docker build, and so I don't screw it up, -T, and I'm going to give it an image name. I'm going to call it ASP.NET Demo 4, and when the -T, just one or two, just one, -T, the first one's your main image, and then the second one is the tag. So you can have, I could have multiple ASP.NET Demo 3s of different versions, and the second tag would be the version number, and it discretely identifies each one of them. But I'm going to follow the same pattern here. So I'm telling it to build from this folder, which has the Docker file in it. It's the one we looked at inside of Visual Code in Visual Studio Code. So if I run this, that's all the apt-get stuff that we saw in the run apt-get.
So from the Docker Hub, you've got an image of Windows, or Windows, and inside of that you use Yeoman to generate the ASP.NET.
Well, the Yeoman ASP.NET creation is nothing to do with Docker. It just happens to create a Docker file if you want to do that. So I can create an ASP.NET app cross-platform using the Yo ASP.NET for anything. I can deploy that on its own, run it on its own. That's not Docker specific.
Right. Your images are both right. Base image.
The base image that was in here was the one that they used for the Microsoft ASP.NET one. That was my base image. Huh?
What was the OS?
It's Debian. I don't know if it's full. I don't think it's full Ubuntu, but that's kind of hidden for me without searching around inside the image as to what's in there. That's hidden for me because I started with the Microsoft ASP.NET image as my starting point, so I can go back to their site and research what they used as their base. But so that created for me. If I do Docker, so now I got a new ASP.NET 4. Created from that Docker build file that told it what to do. Okay, so I'm going to go run this one. I will copy the. I'm going to run the one I already had built because I know that works. So now that I have my image built, I'm going to run it. In this run command, the -P is I'm mapping the ports. So I'm saying that port 5000 inside the container is going to be accessed by port 80 on the outside of the container. So that's one of your control things that you get when you run this in the Docker machine as to how you're physically going to access it. So again, inside the container, it's a self-contained operating system running, listening on ports, but it's listening inside on port 5000 to do its thing. And then the machine's mapping port 80 from the outside to port 5000 on the inside. So this name parameter I'm putting in there because if you don't, then you have to go look up this easy to remember image ID to look it up after you do it. So I create it using a a named instance so that I can use that name to see it. And then this last one is the image that I'm going to run. So I'm using my demo 3 that I built before, and so if I run this, all right, so it's telling me the information you see there is what the ASP.NET Kestrel web server is displaying inside of the container. It's just standard out's just being ported to standard out outside the Docker machine so I could see what was happening there. So so this is from earlier. I'll refresh it. Okay, so we looked up our IP address before for the machine, so that's the IP address. I'm doing port 80 by default because that's what I mapped when I ran it. And then if you go back here to where I ran the container, you can see the console logging information that the ASP.NET app is, the Kestrel server is doing, is writing it out to standard out, which again gets ported out to the outside of the Docker machine. So that Yo ASP.NET template, it provides all this for you with a spot to put your own about page and your contact page. It's just
It's very
standard
similar to
stuff.
the one that you can generate with Visual Studio.
Yes, yeah, they just kind of duplicated that. So I just throw it in there to show the .NET running inside the container, and
So you could configure it to have any parameters like a database connection or volume of storage.
you can send args in that get mapped to things, or you can set environment variables that get set to things. So you can make it configurable for that container of what kind of things you're going to point it to. So yes, if you wanted to go to some other database for production, obviously, then you'd have a different script for launching it in production, and you could pass in the production connection string as part of the launch of the container, and it would point to something different. Sweet. So let me,
Instead of passing that in to the command prompt, did you have the properties in a project file of some sort and just have it run and stuff in everything that way?
I don't know. I know it reads environment variables, so you could set up a bunch of environment variables. I don't
Well,
know.
If you use
I don't know if you-
compose and you're running multiple containers.
Yeah, all
in
that stuff
Compose,
can go in
all
Compose.
that stuff goes in the compose file.
Right. Yeah, and we'll get to that. I got a compose example that we're going to look at. But if you're just running one instance and you want to load it for property, there may be I didn't look at all the arguments that you can pass to Docker run, but there may be one where you can say read the information from this file to run. Or it's Unix. Do a text file, type it into the command line, and you've got the same results.
Where did you get the IP address that you were pointing at?
Okay, I'll show you a sec here. I'm trying to make this big enough so you can see the commands again on this guy. It's kind of annoying that it makes my window bigger every time. So if I do Docker machine IP, it tells me the IP address that my machine's running in. And I don't, I've got my cheat sheet here that I'm looking at on the other screen for all these commands, so I'm not doing them off the top of my head.
The whole machine is running on a specific IP address. And then when you started up that container, I guess, it gave you an address 0.0.0.
Okay, yeah, that you saw was what got displayed by the Kestrel web server that's running inside of the container, and it was just writing that to the console as it launched. So inside the container, Kestrel thinks it's listening to 0.0.0 5,000. But externally, all the access to that container is controlled by Docker machine, and externally, I mapped it to port 80, and it's at that IP address because that's the one the machine's running. So all of the containers are going to run off that IP address. So if you only have one Docker machine instance running off this IP address and you want to run things off the same port, you'd have to have multiple machines running, right? I'm sure there's a way, since it's VirtualBox, there's a way to assign multiple IP addresses and all that. I didn't get into all that, but I'm sure all that's configurable. So something else we can look at here. We have Docker ps-a. That's showing me a loaded container that's loaded in my Docker machine. This will list all of them that are loaded in. I only have one right now. And it shows that it's currently running. It shows how it was run. It's a little hard to see because it wraps, but and here at the end you can see the name that I put on the command line. So I have a friendly name that I can use to control this process. So I can do Docker stop ASP.NET demo. And now if I do my list command, it shows that it's still loaded in memory, but it's exited. Okay, it's not executing anymore. And if I flip back over here to my tab where I initially ran it, you can see it exited out. It's not streaming the stuff anymore. The container's not doing output anymore because it's out. There is a command. I wanted to show this stuff on the screen. If you put a -D in the run, it'll run it as a daemon, and it'll come right back to the command line and won't take up your terminal window. But I didn't do that for this demo because I wanted that stuff on there so you could see it was running in the background and all that.
So is Docker Compose only for deploying, or is there something that monitors it to make sure it's always up? Like if you have a website, you want it always running.
That's a whole different set of tools, and that's part of like Docker Swarm and some other third parties that can manage that stuff. That's not out of the box. Docker's giving you the platform, and Docker Swarm is giving you some of the other tools. Compose, we'll get to that in a second, but Compose allows you to group together containers and then manage them as a set. So I can run this group of containers as a solution, and I can take them down together and all that. So what do we have for time?
25 minutes.
Okay. So now that that's exited, there's another little command here. Let me see if I got it in my history. Nah, I guess I just have to type it. There we go. This handy little command here will go through and it gets a list of all the container instances that are stopped, and then it removes them. So if I run this and then I do my oops. Now you see there's no more instances running. So that's how I clear out. I can start and stop them and leave them in memory, or I can stop them and then clear them out with this, and it takes them totally out of memory. So,
Does that take up a lot of memory?
Well,
Is it a bad idea to leave them in?
well, it depends on how you want to manage your resources. So this shows you that my ASP.NET 3 demo, that image is 1.3 gig, and that's just the image. You know, when it launches in memory, it's going to take up memory and other stuff too. So it's decent size. I mean, this is just managing these command lines. I'm just managing your local development stuff. Production would be a different story because you'd have different rules about what's up and how you scale and how you're going to divide up your resources and all that. That would be a different scale than this. But I was a little disappointed in that. If you look at part of it's probably because of if you load the .NET stack, .NET's expecting to be able to do all this stuff, and to be able to do all that stuff, you have to have all these OS services in place in order for it to do that, so that's probably why it gets so big. But the bare bones Microsoft ASP.NET image is 815 meg, so it's just under a gig just for the image before you put your app in it. So, but again, the reason Docker's getting popularity now and may not have 10 years ago is because there's infrastructure guys in here, they don't want to hear this, but storage is cheap, memory is cheap. So you don't get hung up on its 1.8 gig, because the time you save in being able to manage your resources far exceeds the 150K it might cost you to add to your SAN or something like that. So in relative terms, it's efficient, but it all depends on what your expectations are in efficiency. So
Lost hair. Lost hair.
Yeah. Yeah. So let's go to, there'll probably be some discussion around this. So let's go to the other concept here. Docker Compose, I mentioned earlier, allows you to put multiple things together. So this is a simple compose file. You're defining your services that you're going to use together. So in here I'm using two. I'm defining a web service and a MongoDB service. And those are my names. They're not, that doesn't imply what they are. I could call that Fred and George. Okay, I just named them what they were. So in the first one, I'm going to use my image I already created. And then I had to put in my ports so that the mapping happens, the stuff that I put on the run command, because Compose is going to run it for me. So, and I had to specify this. I can go back. I might be able to take this out. I put this in here because initially it didn't work, and it may have been because of this. But I put this in here just in case, because when it tells us to execute, it's supposed to run this. So I wanted to make sure that it did. So if I put this in here, this will override the entry point that was specified in the Docker file build. But it should have been the same, but I put it in there anyway. Then this is the key here where it says, well, I'm going to use database for this, so it depends on this other service. So now I'm defining my other service, which I'm defining the ports, the standard Mongo ports, and that's the image I'm using. And I built that image. I cheated on this one. I built the image this morning, but I went out to somebody very nicely on GitHub, had a Docker file already created for building the MongoDB image. So all I had to do was pull down the Docker file and say, build it, and it built it. So I had to pull down the Ubuntu. Ubuntu's got a whole bunch of images out there. I pulled down the 1404.4 LTS one, and then I built the Mongo image in it. So this is saying that I in order to run this, I need my ASP.NET app, and I need this database. So let me jump back over to here.
Can you talk to whether or not you need to externalize, like if you're running a swarm of microservices in multiple Docker containers, there's going to be some network IP ports that don't need to be exposed outside of the container environment.
Exactly. Yeah. Exactly. Good point. Let me talk about that here.
Did you actually expose that Mongo port right there?
If I don't do this, then those ports are only accessible between the containers. But I did this because I want to run the Mongo client and show that this is up. Okay. And connect to it and do it. I did this on purpose. But you can configure this in Compose so that this ASP.NET image is talking to Mongo, and it can only communicate between these two containers. So if somebody else tries to connect to your Mongo database, they can't see it. That port's not exposed. It's exposed between the two containers, but it's not exposed to the outside world. again, I put it in here specifically, this exposed it, and I did that because I wanted to be able to, from my host, connect the Mongo client to it to show that it's up and running and I can look at it. But if you were deploying this to production, and you only needed this guy to talk to it, you could exclude the external port mapping, and the two containers could talk to each other, but nobody else could talk.
All containers can talk to each other by default?
There's configuration options around that, but the default is only container to container, and you have to explicitly say, no, I want external. So any combination of the two, you'd have to explicitly put that in the compose file.
Is that containers with the same host, or could they be pressed for an overlay network?
Well, I'll admit that's outside of my knowledge base. In Swarm, I don't know how much Swarm makes it look like one machine. I'm assuming since they went to the trouble of making Swarm, that I don't have to do anything special in my compose file. I can put it out there and it'll let me manage it using the Swarm tool. That's what I would expect to happen, but I don't know that by experience. So
if you didn't define any of those ports, it wouldn't be accessible at all from the outside.
Well, right. If I didn't define these ports, these two images would launch. They could talk to each other. ASP.NET could talk to this guy, but nobody else could talk to him. So I have to do this, because if I have a web application that's not exposed, there's no point, right? So I have to do this one, but I didn't have to do this one.
Right. Just to show us that.
Yeah, it's just so that I can connect to it with a Mongo client. So if I go back to here, and I think it was in my history. I want to make sure, let's see, I got nothing running. I don't have any images running right now. All right. So instead of run, it's Docker compose up. And it's going to look for the Docker compose.yml file, which you can see at the top of my terminal there. It's going to look for that by default. And hopefully that's still in my history. Oops. All right, so inside of Docker Compose, when it ran, it created these, based by mangling the names together, it created an image for MongoDB1, and it created an image called, remember when I put name in the Docker run so I could call it something? They created a name on the fly to call that process, and it's Mongo1 and Web1. And then it just goes through and launches those two containers with the information that was provided in the compose, but they're both up at the same time. And because I did a depends, it runs MongoDB first because the web depended on it. So it runs MongoDB1 first, and then it runs the web one after. So if I go back out here to my web page, still comes up. I refresh it, still comes up because it's still pointing the same thing. I don't have the web app talking to MongoDB right now. I didn't have enough time to do that this morning. But if I go to oops. So in here, I'm going to run Mongo client native on my Mac, but I'm going to tell it to connect to that same host that we got from the Docker machine. And if I do that, it connects. So, let's see, does it show these? So, I'm connected to that Mongo instance that I launched along with the web app and looking at the database in it through the Mongo client. So they both launched at the same time, or relative to each other anyway. Is it quit or exit? So let's go back over here while those are running, and you can see if I list them, there's that MongoDB 1 that it showed me at launch, then there's the web showed me at launch. So I still see the containers in the container list. Let's see, is this still? Yes. So now if I do Docker. So I do Docker Compose from the same folder. It goes out, looks at the Docker Compose file to see what services are out there, and I can control them from all together, so I can bring them all down at the same time. So if I do my PSA again, it's going to show they're still in memory, but they're exited, they're not running. Let's see. I got a few more minutes. So, any questions? At least it waited till the end. I'm wondering if that QuickTime thing took up too much memory and it just said, I'm done.
So you could have actually launch multiple instances and have the load down for dedicated images. Could you have done that on a single host?
Yeah. There is a way to do that. I didn't get that in depth in how you, but in Compose you could set that up and say that I'm going to run these, and then I want these to respond. Yeah, you do it all through your port mapping. And
So I don't know whether you run into this, but I've played with Docker and downloaded a bunch of stuff from Docker Hub, and a number of things have not built properly. Some of them have been composed, some of them have just been a standard Docker container. But trying to do Docker build, and you run into at one of the bottom steps in a compose, like step 9 or whatever, trying to do something with Node.js, and I'm installing a bunch of different things, and something goes wrong, and you see stuff on the screen of what went wrong in the build process, but it's verbose.
yeah.
I just wonder, have you run into how do you debug when
The
Docker
Compose
doesn't,
script?
Well, when Docker doesn't run, what do? And do you ignore that container and move on to something else to work on, or does anybody get into Docker debug?
I've never gotten into the Docker debug stuff, but in that instance, if I was trying to do a Compose, I would take out the one that was a problem and do it its own Docker file and make it work on its own first. And then once I got that ironed out, then put it back into Compose as part of the other stuff. Try and just minimize the.
I think what somebody else said to me is if you did them step by step yourself, working on each Docker file, you basically do it manually.
Oh yeah.
Basic. But it doesn't seem like there's.
Well, you
don't get the same kind of file record of what's happening with the Docker when Docker builds, because it's not building it's building everything for its container. And there should be some log files and stuff, I would think.
Well, what I didn't show you, what I was going to was, you can run commands inside the container. Mm-hmm. So it's a fully running.
Sure. You can actually compose a Docker file that way. You can go in, start with
anything
OS and
anything that would help me try and figure out the problem in the Linux environment, I can just remotely run and try and figure out what step. Like you said, like the guy said, do it by hand. But you could go through the process that Docker was trying to do and do it step at a time and get the actual feedback from apt-get or whatever, or from logs. I'm sure you could do it that way. Because, you can manipulate, you can run the container like it's a little virtual Ubuntu or Debian virtual machine, and you can, from Docker, you can run any command inside that machine that you wanted to.
The other question I asked, and I was asking it of people who were giving Docker tutorials, so I expected that they had a lot more knowledge than I did. I said, so you bring down a Docker container from Docker Hub, and you've gotten all the up-to-date Docker tools, and you're on an OS that's a VM that Linux containers run innately, so Docker should be running normally, right? Now, does Docker use any of the environment of your Linux machine to build any of its Docker stuff? Or is Docker running its own tool set when it runs to build the Docker container? And he got a little fuzzy on the answer there. And because I was looking at dependencies, and I said, if I have a problem running this Docker Hub container, maybe it's because the environment that I've got isn't properly set up to run it.
Well,
Because in,
I don't know the direct answer to that, but my deduction on that would be if you ran the tools, like apt-get or whatever, to install the Docker tools, and they installed without, that means they have all their dependencies. So I would expect it to work fine. And
So is the build environment the Docker build, when you run Docker build, is Docker build running Docker's tools that it installed when you installed Docker? Or is it running a build environment that's part of the container?
what do you mean by build? I mean, because
You know when you do
Docker
Docker
build,
build.
well, that's all Docker.
Yes.
That's all Docker.
Right.
So what are you asking?
You're saying if you had like a different version inside the Docker image versus your local computer, and they're like at a conflict.
Well, when you're producing an image that's going to run, for instance, when I put Node on my machine, I actually install it on the machine. I have to have all the dependencies that Node requires on my machine when it's running. When it's building up the container,
Oh, I see what you're saying.
it's doing it step by step.
Is it pulling your node or is it doing another one?
Yeah.
I don't know the specific, but it's going to pull. I would say it's going to pull another one because the Docker environment should be isolated, and I can pull whatever version of Node I want.
Right.
And I wouldn't expect if I built
It
it.
should be the version that I got for the container builder, not my version.
Well, not only that, but if I built it and I built a container, I would expect that if I went back to my host command line and there would be no extra node out there. It wouldn't
Right.
be known to my host.
Right.
Yeah.
But see, so I'm running into those even how to ask those questions of the experts. I did run into somebody who set up a Docker swarm in an hour-long section.
Oh yeah.
Yeah. He was really good, and he could type with both hands, and still talk to the audience and stuff. And I asked him afterwards, can you run through a session where you actually learn how to use the tool set methodically, and you go into the details, and if somebody asks you a detailed question about builds and stuff, you can say, yeah, let's deep dive into that. So he was, and there used to be a Docker meetup specifically for Docker where they were going to run sessions, but I think they canceled it.
Well, Docker itself is, I mean, this is just enough to get you up and running and be dangerous. Docker is very extensive. There's a lot of features and options, and just about anything you can do with the infrastructure, you can do with it. So it could get pretty deep depending on what problem you're trying to solve. So.
Because it may not be that complex when we dive deep into it. All these things are because I had set up MongoDB and Node.js as separate images and containers. I didn't face any issues at all rather than the initial setup, because when you are running in Windows 10, the only prerequisite for having a Docker machine and creating a build is to have the virtualization options enabled. So what happens is, in line with it, it doesn't have to be Linux or Ubuntu at all, because recently Microsoft had come up with Windows Server support. I think it's last week or so. So we don't always have to go with apt-get or npm, but when we are concentrating more on the very minimal size, yes, there are few OSs which can be like in a bootstrap mode, just 100 MB. Then it will be sufficient for us to run a Node app on it, so that the overall size is just 150 MB, so that's a value add. And to answer your question, wherein overall advantage of Docker is to avoid the dependencies. So when we are having the same set of version configurations run in order to create an image, we don't have to worry much about having Node installed locally or even MongoDB installed locally. In the example that you just showed, wherein connecting MongoDB into a specific port, MongoDB was already installed in your local machine.
Yeah, I have one on here
So
too.
situations like this may not occur because we tend to have an inconsistency between the host, the local system that are running Node and the containers.
Well, I hear what you're saying, but what I was trying to do where I ran into problems was a mean stack. Which has Mongo, it has Express, it has, Angular, and it has Node.js. It has to install all of that stuff, including the Node package manager and everything. And it almost looked like it was doing the same steps when I was using Compose. It almost looked like it was building the same stuff that I would do when I'm installing all that stuff on my Windows machine.
Yes.
Well, it does.
If it's doing that, well, yeah, but if it's doing that, if it's a Docker Hub container, shouldn't all of those dependencies already be part of the container?
Depends on which container you started with.
So I started with one that said, go and get all the new stuff? Is that what you're saying? Or how do I choose? If I wanted one that was pre-built that I could just run, how would I do that?
There's multiple Node ones out there. I did a Node one this morning.
Yeah.
I didn't do a whole mean stack, but I did a Node one. I just went out and said pull Node, and they have a list of tags this long, so you can do Node 5.1, 5.11.1, or whatever version of Node you
Which
want.
version of Node you want. So I don't know why when I did Compose, it actually looked like it was building and installing the stack one step at a time, like it was building from a set of Docker files.
When you were doing the mean stack, were you putting it all in one container, or were you building multiples?
It's a Compose, so it was multiple containers.
Okay.
But
yeah.
It knew how to put them all together. It stitched all the IOs and stuff together, but it unfortunately, it got to like step, like I said, 19 or something, and then it said,
basic step.
sorry, you can't build this, and then the whole thing.
One other basic step that you may need to check is whenever we are pulling some images, the first thing Docker does is it looks for some local presence of the same image. So just as an oversight, if we have the same image, if we happen to have same set of files on the host, there may be some issues on that.
Maybe after I tried once and it didn't work, I didn't wipe all that stuff out. Maybe I needed to go and wipe it all out. But and I think I actually got a second container, a different mean stack, but there are, like you said, a bunch of them.
Interesting issue.
I'll eventually figure it out and tell her.
Well, I want to thank everyone for coming today, and keep us in mind every month we do really cool topics. And Rich is doing one on AngularJS in August. I'm going to do one in July on IoT and some machine learning. We're still looking for a June topic. So any of you guys, particularly from Logical Advantage, if you have some ideas, please come talk to me. We'll get June booked out. Thank you. Thank you, Marty.
Mm-hmm.